Hey guys, welcome. Today we'll be talking about road traffic analysis. But why? Why do we need to do this road traffic analysis? What is the application of this project? From this road traffic analysis project, we can do a better transportation planning. We can find out road capacity. We can do traffic signal optimization. We can find a better way to do congestion management. Now, if you want to learn more about this traffic analysis, this existing data collection system, you can visit all these websites. You'll get a good understanding of this traffic analysis and why do we need this. Why do we need to integrate AI in this traffic analysis system? I'll give this link in the description. Now, here in our project, this will be our input image. When we run our code, our output will look like this. So you can see we are printing out the counts at these critical locations. You can see this is position 2, this is position 1, this is position 3, and this is position 4. And here if you look at each object, you can see we are printing out the bounding box, the class ID, the tracking ID, and the speed of that particular object. Now here the pipeline will look like this. We'll give the image to YOLO. It will give us the bounding box and the class information. Then we'll pass this bounding box to OCSORT tracker. It will generate ID, and from these tracked objects we'll be doing our counting, we'll be doing our speed estimation, we'll be plotting trails, we'll be plotting heat map also. So if you come here, you can see this will be our input video. You can see just a plain simple aerial view of this roundabout traffic, and when we do process, we'll be creating all these outputs. So here you can see this is the output that we have been talking about. You can see all this counting here. We are operating the counting here also. The RY is blinking when an object crosses. That means the RY color changes to white. You can see here. And then we have this output. Each dot represents an object and the color changes with respect to the speed. You can see like red color means the object are not moving, and you can see the different color represents different speed. Then we have this output. So here we have split the entire frame into 40 by 40 grids. So basically we have created like this. We have split the entire frame into this number of grids. Then we are estimating the average speed within each grid, and then we are putting color based on that average speed information. So red means you can see like here the object speed are like 0 to 20. You can see 0 to 20, and then yellow means 40 to 60, slightly orange means 20 to 40, and then 60 to 80 means green, and 80 plus represented by blue. So then we have this output. You can see we have the original output video. Then here we are plotting the trails of each object. In this analysis, we can identify the area where the traffic is higher, where the congestion is higher, so that will be more focused on those areas during planning our transportation system. Now we have this video also. This is just plotting the trails, you can see here. And then we have this final analysis video. So here we have everything. We have the output video, we have the trail video, we have the speed dots video, you can see, and we have speed heat map video. So for each object we are drawing center of the box, the bounding box, then class name, you can see the tracking ID and speed. So in this project we are using YOLO for object detection, we are using OCSORT for tracking. So here this is the GitHub of YOLOv10 and this is the GitHub of OCSORT. So guys, you can switch OCSORT with any of these trackers. Now if you want to learn how to train YOLOv10, we have created a video earlier. You can follow this video. We have described everything. So here for this project we have already trained our model, and we have a YOLOv10 weight, and we'll be using that weight for this project. Now let's check our code. So this is the code that we'll be using for our project. You can see it has everything, and it will create all those output videos. So here first we are importing all these required libraries, then we are importing YOLO, we are importing OCSORT, you can see here, and then here we are giving the path to input video, we are specifying the output folder. Then here you can see we are specifying path to all the output videos we have seen earlier, and then here we are checking like whether GPU is available or not. Then here we are loading the YOLOv10 model. You can see we are specifying the confidence threshold, that is 0.75. then here we are initializing the tracker, you can see, and here we are creating a bunch of variables and a bunch of functions which will be useful in our project. Here we are defining different colors for different classes that we have in our model. Then here we are selecting the color for this different positions. Remember, we have different color for different positions, so we are defining here. Then here we are specifying a particular area for a particular position. So for example, if you look at here, the logic will be, you can see objects will be moving from left to right. That means when an object crosses this RY, it should get counted. But here if you look at here, this entire thing will have the same X value. For this position we don't have to worry about this area and this area. That's why we are specifying an area, you can see, and here the condition will be if the object enters into this area, and then if the object crosses this RY of that area, you can see, then it will be counted for this position. Similarly, if an object enters into this area and if it crosses this RY, it will get counted for this position. That's why we have selected all these coordinates. Then here this is calculating the RY, that means this is calculating the location of this RY lines which will be using for counting. Now this function is responsible for detection and this function is responsible for tracking. Let's do one thing, guys. Let's understand all these functions one by one from here. So basically when we run this script, it will load everything and then it will start from here. It will start executing from here. First it will execute this function, and you can see we have defined all this path and all this variable in the beginning of the script. You can see here. Now let's check this function. So this will be this function. You can see we are giving all this input to this function. Then here it is loading the video, you can see. Then here it is extracting crucial information such as width of the frame, height of the frame, FPS information. Then here we are creating multiple video writers because we are creating multiple outputs from our input video. We have seen this earlier. Then here we are creating a canvas. So guys, you can see this will be our original frame, and this, you can see, these canvases or these frames are created from this original frame. So the size of these frames, you can see, is similar to this frame. So we are creating that canvas here. Then here we are creating bunch of variables to keep track of information like cross object, counted object, blinking state, blinking frame. So this blink state and blink frame, you can see guys, when an object crosses on a ROI, the color changes to white and then it changes back to the original color. So these two variables here you can see we are creating to perform this mechanism. Now here we have last position to keep track of last position of objects, and then here we're keeping track of object speed. And now here we have started reading the video frame by frame. Now here we are using this function to create this image. So this is nothing but the plotting of grid information on the frame. In this way we can visualize like whether we are creating correct grids or not. So basically here each grid size is 40 by 40 pixel, you can see. So each grid size is of 40 by 40 pixel, and then it is plotting information like it is plotting this represents y value, this blue line represents x values, and you can see like all these 12. So this grid will be 12 and 4, and this will be 12 and 12. Similarly this will be you can see 13 and 31. So after that here we have plotted that information to make sure that we are creating the good grids. Then here we are doing our detection. So here we are passing the frame to this function, you can see. Within that we are passing the frame to our model, it is giving some results, and then from these results we are extracting bounding box information. You can see x1, y1, x2, y2. We have confidence information, the confidence probability from our detection, and then we have class information, and then we are returning all these values. Now after the detection we are passing those values to our tracked objects. So this tracked object function, it will pass these detections to our tracker and it will update our tracker. Now by doing this our tracker will be able to keep track of all the detections that we are getting from our model. Now after that here detection is done, then we have tracked objects, so tracking is done here. Now we have a bunch of objects with unique IDs. Now after that here we are drawing this blinking count ROI information. So basically this function is responsible for that blinking effect that we have seen earlier. You can see here it is using blink state. If blink state we have a true value, it will turn into white, otherwise it will give the original color. Now using that it is plotting the white line or the line with the original color on the frame. Now after that, okay, here, so this is done. After that here we are looping through all the tracked objects. You can see we are extracting bounding box coordinates here, then we are calculating centered x and centered y. Then here we are plotting the bounding box and the centered of each object, you can see. Then here we are estimating the speed, and then we are saving the previous location also. If you go to this function, you can see this is like finding the Euclidean distance. Here it is converting distance in pixels into meters. Then here you can see it is calculating the speed. Then it is converting speed in meter per second to kilometer per hour. Let's understand the speed calculation in this way. So we know speed is equal to distance by final time minus initial time. So let's think that we have this road, we have this car, and the distance between these two ROIs is 100 pixel. So when the car is at this location, we have like t1 equal to 0. Then when the car is at this location, you can see we have t2 equal to 20 seconds. So 1 meter, here we are considering like 1 meter is represented by 10 pixels. Hence 1 pixel is 1 by 10 meter. So speed is equal to 100 by 20 minus 0. You can see using this equation. Now here we have 5 pixel per second. The speed is 5 pixel per second. Now if we convert that into meter per second, we have 5 into 1 by 10. You can see we have 0.5 meter per second. And if you want to convert this meter per second into kilometer per hour, we have to do like this. Now this speed, this 5 pixel per second, is now 1.8 kilometer per hour. This calculation is represented by this function. Now after that, here, okay, so we are done with this speed estimation. We have speed of this object. Now you can see here we are performing the counting. So remember, we have discussed the object should be within this area, then it should cross this particular RY to be counted for this position. So same thing is happening here. So here first we are checking whether the object is within this area or not, and if yes, then whether we are checking the direction. Here you can see we are checking the direction, because for this RY the direction would be top to bottom, for this thing the direction would be right to left, and this thing the direction would be bottom to top, and for this thing the direction would be left to right. So here we are checking the direction, and according to that we are determining whether the object has crossed or not. And if the object has crossed and it hasn't counted yet, we are counting the object, then we are updating the relevant information, and then here we are selecting blinking state, that is true, and blinking frame, that is FPS. Now you must be thinking, why FPS and why all this calculation? So let's take an example. Place an object crosses position 1 at frame 100 and the video is of 30 FPS. So at frame 100 the blinking state position is set to true. This is true. And then blink frame position is set to 30. You can see this is FPS. So for frame 101 to 129, the position 1 will be drawn in white, and after that the blink frame will be 0. You can see, and then blink state will be false. That means after this the color of this RY line will be turned back to the original color, just like this. When you can see, when the object crosses, it is white, and then it return to the original color. After that, here we are putting all this count information on the top left corner of our frame. You can see all this information here. Then here, then draw counts near RY. So this function is creating this counts. You can see for each RY it is showing the counts also. You can see counts 18. So this function is doing that. It is extracting the relevant information, the position information, and the critical RY information, and then it is putting the count information near to that RY. You can see. After that, here we are creating this speed dot analysis, this frame or this video. So this function is receiving all this information. It is looping through all the tracked objects. You can see it is finding the speed of each object, and then it is selecting color based upon the speed, and then it is plotting the circles and the information based upon these requirements. So that function is creating this video. Now after that, after creating the speed dot information, the speed dot visualization, we are creating visualize speed area map. So basically this function is responsible for creating this video. You can see it is creating the grids here, you can see. Then it is looping through all the tracked objects. It is finding out the grid information, and it is finding out the speed information also. So basically what it is doing, let's say we have a frame of 1280 and 720 pixels, which gives us a 32 by 18 grids. So basically if we divide this pixel with a grid size of 40 by 40, we'll get 32 into 18 number of grids. And let's say we have an object which will be having this bounding box, you can see here. Now from this bounding box we can calculate the centroid, and that will be 180 by 220. So by doing this, you can see, so by doing this we can find out at which grid location this object is currently at. That means if here for this object the grid location will be 4 and 5. That means this is, you know, grid location 1 2 3 4, this is x value, and this is 5. So the object would be at this grid, and then using that information we are increasing the count and we are increasing the speed. Now here we have defined a preset colors for a speed limit. For example, if the speed is between 0 to 20, use red. If the speed is between 20 to 40, use orange. And then for 40 to 60, yellow. 60 to 80, green. And 80 plus, use blue. So basically you can see when we have blue color, that means the car is traveling at a speed of more than 80 km per hour. If we have red color, you can see that these cars, they are stopped here, or their speed is less than 20 km per hour. And this color defined, you can see like this is between 20 to 40 and this is between 40 to 60. So we have defined these values for that. Now here you can see we are looping through the grid size, then we are finding out the speed, the average speed of each grid, and then we're changing the color for that grid based on this average speed. And then here we're just plotting all this count information here, RY, all this legend information. You can see this legend information on the frame. Now after that, so we are done with this visualization speed area, and we're done with this creating speed dots. Now here just we're plotting this, all this blinking count ROI. We're plotting counts near ROI on different videos, you can see. Then here we are creating the trail video. You can see this is the trail video. Now this video is created by this function. You can see here it is looping through all these tracked objects. It is extracting the bounding box information. It is calculating the centroid here. Then it is, it is appending the centroid information to the existing trail information. Then here it is drawing the trail, you can see. Now okay, so we have learned how to create all these separate videos and which function is responsible for which video. Now after that, I think we are done here. So after that, here we are just writing all these separate videos using the video writer we have created earlier. Then we are creating this combined frame using this function. So here we have frames and then height and width, all these things. And then here you can see we are resizing everything and we are stacking all the frames together to create this combined output. After that, we are writing the combined output to a master video. Then here we are releasing all the video writers we have created earlier. This is the whole code for this project. I hope you guys liked it. I hope it was helpful. Please like, subscribe and share. I'll see you in the next video. Till then, take care.